Surface area. Surface area is the total area of all the faces or surfaces of the three-dimensional object. So to find the surface area, we add the areas of each side. In other words, we find the area of a net. For example, for this rectangular box, if we cut it out, we're gonna have all the areas around. So imagine you could unfold a three-dimensional object and lay all its surfaces flat. The combined area of all those flattened surfaces would be its surface area. Surface area is measured in square units, for example, square centimeters, square meters, square feet. The only difference is for surface area of the sphere, it's a separate formula. It's basically what is on the surface of the sphere. So to calculate the surface area, for example, on this box, we're gonna calculate the area. We're gonna calculate the area of the bottom. This is the area right here and right here. Then we're gonna calculate the area of the front and back. Here is the front, here is the back, and we're gonna calculate area of the sides. Here is one side and another side. And then we're gonna add them all together. Similarly, for the cylinder, we would calculate the area of the bottom, which is the circle, area of the top, which is also the circle, and if I cut this halfway through, I'm gonna have the rectangle on the way. And this similarly for pyramid. So let's see some examples. Surface area actually has a lot of application in real life. For example, wrapping a gift, the amount of wrapping paper you need to cover a present perfectly is the surface area. Another example would be painting a room. When you want to paint a wall or a fence, you are calculating the surface area to determine how much paint you will need. Or packaging, it's using in manufacturing. Some companies trying to figure out the minimum amount of material needed to create boxes, containers, and so on. In architecture, in construction, builders use surface area to determine the amount of roofing material, siding, or insulation required for buildings. In engineering, aerodynamics, surface area and the shape of an aircraft wing or car body influence the drag and the lift. In chemistry, the surface area and to volume ratio of a cell is crucial for nutrient absorption and waste removal, and so on. Example 1. Find the surface area of each object. So let's label it. This is my part A, this would be my part B, and this would be my part C. So let's calculate the area, total surface area of this box. So we need to calculate the areas of each and every one component. So let's start with the part A. We would start with area, and let's call it front and back. And this would be the area of the front rectangle, so that's exactly this one. Area of a rectangle is length times width. In that case would be length times height. So what we have 3 times 6. 3 times 6 is 18 centimeters squared. Then we're gonna calculate area of the sides. So this would be this area. One side and the other side is the same. So this is this area right here. So the side is also a rectangle. So area of rectangle is length times width. So it would be 2 times 6. So this is 12 centimeters square as well. And then we need to calculate area of the top and bottom. If we calculate area of the top and bottom, so bottom is right here and top has the same area, those ones are right here. So this would be this length times the width, or in other words, length times the width right here. So this is So this is so this is 3 times 2. In that case, we have 6 centimeters square. And the surface area for shortcut, we're gonna write SA, surface area, is the total area. But we need to count them. For example, we need to count the front once and then the back. So we need to either multiply times 2, or we need to do it 18 plus 18, because front is 18 and then the back is 18. This front is 18 and the back is also 18 centimeters square. So we're gonna have 2 times 18 plus 2 sides. We have also 2 sides. Here is my one side and this side is 12. Here we have another side, also 12. So we need to multiply times 2 times 12 plus the same with the top and bottom, 2 times 6. The top is here, it's 6 plus another 6, or 2 times them, 2 of them. And when we add this all together, 2 times 18 is 36, 2 times 12 is 24, 2 times 6 is 12, and if I add all of that together, I will get 72 centimeters square. So the surface area for part A is 72 centimeters square. Part B, we need to calculate area of the bottom, which is circle. How do we calculate area of the circle? Area of the circle is pi r square. So in my case would be area pi times r is 2 square. So this would be equal to 4 times pi, which is, use the pi button, so would be 12.5663, so approximately 12.6. Use the pi button, 4 times pi button, that should give you this, and then you approximate to 0.6 to 1 decimal. 5, look at the next digit is 6, so we increase the 1, it's 5 and more, we increase the 5 into 6. Now the area of this rectangle is length times the width. But what is this length? This length is nothing else but this length around the circle, because this rectangle needs to fit all around the circle. So what is this? Mathematically speaking, it's nothing else but this circumference, because that's the length around the circle. So the circumference, so this length is circumference. How do we find circumference? 2 pi r is the circumference, right? So the area, let's keep this one was area of the circle. Area of the rectangle would be 2 pi r times the height is 4 times 4. My r is 2, so we can substitute 2 here. So we have 2 times pi times 2 times 4. So this gives me 2 times 2 is 4 times 2 is 16 times pi use the pi button, 16 times pi, and we should get 50.265, which is approximately 50.3. For the total surface area, we need to add the bottom and the side, but pay attention because we have circle on the bottom and circle on the top. So we need to add this area twice because this is only one area of this one. So the total surface area would be 2 times 12.6 plus 50.3, because 2 times comes from the one circle and the other on the top. So if we multiply this all together, we should get 75.5 inches square. That's my total surface area. The part C, to find the surface area, we need to calculate the area of the bottom, which is square, and we have the side 3, so this side would be 3, 3, and 3. And then we have all 4 exactly the same triangles. How do we calculate area of the triangle? Area of triangle would be 1/2 base times the height. So we can calculate area first of the square would be 3 times 3 or 3 square, which is 9. And then area of the triangle is 1/2 base times height. So in that case would be 1/2. My base is here, right here, so it's 3, and my height is 4. So times 3 times 4, and this would be 3 times 4. 3 times 4 is 12, times 1/2 is 6. So the total surface area would be the area of the rectangle plus how many triangles do we have? We have 1, 2, 3, 4 triangles. So 4 times the area of those triangles. So we have 9 plus 4 times area of triangle, which is 36. I'm sorry, 4 times 6 is 24 plus 9 is 33. And we have unit meters square. This meter square, we have the unit right here. So that's my surface area. SA stands for surface area. Example 2. A homeowner wants to tile a rectangular swimming pool. The pool has dimension 12 meters long, 5 meters wide, and 2 meters deep. The tiles that the owner likes are 1 meter by 0.5 meters, and each tile costs $9.25. What is the total area of the pool that needs to be covered by tiles, and what is the area of one tile, and so on? So we have a rectangular swimming pool that is 12 meters long, 5 meters wide, and 2 meters deep. So this is my swimming pool. We have 12 meters long, 5 meters wide, and 2 meters deep. So first we need to calculate the total area of the pool. So as before, we're gonna calculate, maybe we can put it bottom. First we're gonna calculate the front. The front rectangle is 12 times 2. Front and back is exactly the same. So the area of front or back is gonna be equal 12 times 2. That's the length times the width. So that area is equal to 24. Now area of sides is gonna be equal. We have a length times width. So this width is exactly the same as this width here. So the length times width. So we are having 5 times 2. So this area is 10. And then area, now we need to calculate the area of bottom and top. We don't have actually top, right? So area of the bottom, so that's this area. It's gonna be length times the width right here. So area of the bottom is 12 times 5. 12 times 5 is 60. So the total area that we need to calculate would be total area is, we have 2 times 24 plus 2 times 10 plus 1 bottom. That means back and forth, front. So we have we have front and we have back. So that's why we need to have two of those. Then we have one side and another side. So we need to have 2 of those. But then we have only bottom. We don't have top because pool is open. So only bottom. So if we multiply this all together, we should get that this is equal to 128 meters square. So this is my part A. For part B, we calculate what is the area of one tile. So here is one tile is 1 meter by 5. So one tile is 1 by 0.5. How do we calculate that area? 1 times 0.5. So this area is 0.5 meters square, of course. Part C, to figure out how many tiles are needed to cover the pool, we're gonna use the total area and we divide by the area covered by one tile. So we're gonna have 128 divided by 0.5, and thus if you type on calculator, that gives me 256 tiles. That's what we need. Now part D, if the one tile cost $9.25, how much we gonna pay for the tiles? So we're gonna multiply 256 tiles times 9.25, and we getting 2,368. So the cost of that project is $2,368. Example 3. A glass company is making a rectangular fish tank with dimensions of 2 meters long, 1 meter wide, and 1.5 meter high. The tank will have a glass bottom and 4 glass sides. The glass cost is $50 per square meter. What is the total surface area of the glass needed for the tank? What will be the total cost of the glass? So we have a rectangular fish tank. It's 1 meter wide. It's 2 meters long, 1 meter wide, and 1.5 meter high, 1.5 meter high. So this is my fish tank. So as before, area of the bottom would be length times width, which is length 2, width is wide 1. So we have 2 times 1, which is 2. Area on the sides would be length times width, which is 1 times 1.5, 1 times 1.5, and this is 1.5. And then we need to have area of the front and back. So the front right here is rectangle, and the area would be 2 times the width. In that case is 1.5, because that's the same, right? So we have 2 times 1.5. So 2 times 1.5 is 3. If we would like to make the net out of that to see it more correctly, that would be my bottom. And then we have the sides right here. And then we would have the front and back, right? So front, this is 2, this would be 2. And then this side would be 1. And the height is 1.5 right here. So the total area, or the surface area, we need to add, we have only one bottom, and then 2 sides, so we're gonna multiply this times 2, and then we have front and back, so we need to multiply this times 2 as well. So the bottom is 2, then the sides would be 2 of them, 2 times 1.5, plus we have 2 times 3. So if we calculate this all together, we are getting 36 meters square, of course, right? Example 4. A manufacturing company is making cylindrical cans. Each can has a diameter of 8 centimeters and a height of 10 centimeters. The aluminium cost is 0.012 per square centimeter. What is the amount of aluminium, or in other words, the surface area, is needed to produce 1 can? And part B, what is the cost of the material? So we have the can, kind of cylindrical can, but we have given diameter, so that would be all across. The diameter is 8, so that means radius would be just 4, right? So we have it, the cylindrical can, radius would be just 4, because the diameter is 8, so height is 10. So if we would like to cut this to see what is material, it's gonna be rectangle and 2 circles, right? And the radius here is 4, and the height is 10. So area of the circle is pi r squared. So area of the circle is pi times 4 squared, which is 16 pi. If we use the pi button, we should get 50.265, which is approximately 50.3 centimeters square. And now this rectangle, so this length is nothing else but the circumference around, because it needs to fit, right? So the circumference is 2 pi r. my R is 4, right? So the area of that rectangle is gonna be equal to pi, my R is 4, times, this is just the length, 2 pi R is just the length, times the width, so we need to multiply this times 10. And if we multiply this correctly, we're getting 80 pi, and then because we can multiply 2 times 4 is 8, times 10 is 80, and we have pi. Then we use the pi button, and we're getting 251.327, which is approximately 251.3. Now, to calculate the total surface area, we would need to add circle and circle plus the area of the rectangle. So we have 2 of those circles. So the surface area is 2 times area of the circle plus area of that rectangle, what we just calculated. So 2 times area of the circle is 50.3. Area of the circle is right here, and one area of the rectangle is right here, plus 251.3. Calculate this all together, and we're getting 351.9, and that would be centimeters square. This is the surface area for part A. And for part B, we would like to calculate the cost of the material for producing 1 can. So the cost is we multiply the surface area times the area per square centimeter, right? So we're gonna have 351.9 times 0.012. And if we calculate this, it's gonna be 4.2228, which is approximately $4.22. So the cost to produce 1 can is $4.22. Example 5. A craft company produces spherical ornament. Each ornament has a diameter of 12 centimeters. The material used to coat the ornament costs 2 cents per square centimeter. Calculate the surface area, calculate the total cost of material, and if the box has 6 ornaments, what is the total surface area, and what would be the cost of coating. So we have the diameter of the sphere. So in that case, we have the diameter of the sphere right here. Diameter is 12, so the radius is just 6. Radius is half of the diameter, because this is one radius, another radius, right? So surface area of the sphere, we have the sphere, and radius is just 6. So for part A, surface area of the sphere is calculated 4 pi r square. So in my case, we have the surface area is gonna be 4 pi times 6 square. Radius is 6. So this is equal, 6 square is 36 times 4 is 144 pi, which gives me 452.3893, which approximately is 452.4. So we rounded to 1 decimal place. To round to 1 decimal place, we look at the next one. Next one is 8. If that's 5 or more, we increase the value by 1. So from 3, we're getting 4. So this is the surface area in centimeter square, of course. Part B, the cost would be, we multiply my surface area times the cost per 1 square centimeter. So the cost is 452.4 times 0.02. And in that case, we're getting 9.048, which is approximately $9.05. As before, we're trying to round it up to whole cents, so to 2 decimal places. We look at the next digit is 8. If the next digit is 5 or more, we increase it by 1, so it's 0.5 cents. So this is the cost of one. This is the cost of one ornament. Now, part C. Part C is asking if we have 6 ornaments, what is the surface area? If one ornament has the surface area, so we simply multiply this times 6. So 6 times 452.4, and in that case we're getting 2,714.4 centimeters square. So 6 of those ornaments, that's the surface area. And part D, what would be the cost of the box? We're gonna use the cost. We're gonna use the surface area, which is 207.14 times 4 times, we're gonna multiply times 0.02, and that cost is 52.29. This is the cost of the whole box. Example 6. A gazebo has roof shaped like a rectangular pyramid. The base of the roof measures 20 feet by 12. The slant height along the 20-foot base for triangular surface with a 12-foot base is 22. The slant height along the 12-foot base for a triangular surface with a 20-foot base is 17. The owner wants to cover the entire exterior of the roofing with the shingles, not including the open base. The shingles cost $6.50 per square foot. And what is the cost? What is the surface area and what is the cost of the project? So we have a rectangular base which has 20 by 12. And we're gonna make it, and we're gonna make triangular pyramid, right? Okay, if I cut this out and flatten this out, I'm gonna get that this is 20 by 12, and then we have triangles on one side, triangle on the other side, and here we have other triangles as well. So the height, the slant height would be right here. So that would be this height and also this height right here, right? So this one of the height is right here, and this is the slant height right here. So we have it that slant height along the 20-foot base for the triangular face with the 12-foot. So here is this 12-foot. So the slant height would be right here. That slant height is 22. So this one is 22. And then the other height is 11.7. So this area of the triangle is 1/2 base times height. So in that case, we have 1/2 times 20 times 11.7. And that gives me 10 times 11. 1/2 times 20 is 10. 10 times 11.7 should be 117. And the area of the other triangle, triangle 1, triangle 2, let's call it, the area of the other triangle would be 1/2. Base is 12 times 22. So we have base 12 and the height is 22. So we have 6 times 22. So this one is 132. So the surface area for the project would be 2 of the triangles 117 plus 2 times the other area of the triangle 132. So it's 498 feet square. For part B, the cost, we need to multiply 4 times 98 times the price, which is $6.50. And if we type this correctly, the cost is $3,237. Cost of the whole project. Example 7. Mr. Jones is painting his living room, which is 15 feet long, 10 feet wide, and 9 feet high. It has 2 windows, 3 by 7 each, and a fireplace 6 by 4 that will not be painted. He wants to paint the wall a light orange. Each gallon of light orange paint is $22.50 and covers the square feet. It covers 300 square feet. What is the total area of the wall to be painted, of the walls? And if he applies 2 coats, how many gallons of paint should he buy? And what will be the total cost of the project? So let's calculate first the area of the window. The window is 3 by 5. So the window is 3 times 5, which is 15 feet square. And we have 2 windows. So we're gonna have it 2 times 15, which will be 30 feet square, of course, right? And then fireplace. Fireplace is 6 by 4. So 6 times 4 is 24 feet square. So the area that will not be painted would be not painted. Area that will not be painted is 54 feet square. All right, now we're gonna paint the room, and the room is rectangular. It says 15 feet long, 10 feet wide, and 9 feet high. So as before, we're gonna calculate front, which is 15 times 9. That's the front and back the same, right? So we have area front and back is 15 times 9. 15 times 9 is 135. Then we have area of the sides. Area of the sides is 10 times 9. 10 times 9 is 90. And then we have area of the bottom and top not needed, right? Because we only want to paint the wall, the bottom is the floor and ceiling on the top. So the surface area to be painted would be 2 times 135 plus 2 times 90. So we have two of the walls. One wall is front and the other wall is back. So we have 2 times 135 and one side is 90 and we need another side is 90. So the surface area is 2 times 135 is 270 plus 180. The surface area is 450 feet square. And then we need to subtract what is not painted. So we're gonna subtract minus 54 and we getting that the total area to be painted is 396 feet square. This is the area to be painted. Mr. Jones wanna apply 2 coats of paint, so we need to calculate now 2 coats. So we're gonna have 2 coats of paint would be 2 times 396, and in that case is 792 feet square. So that's the total area. Now, one can covers 300 square feet. So how many, if we have 792 square feet and one of them cover 300, so we would need to simply divide 792 divide by 300 and we getting 2.64 of cans. We cannot buy half of the can, so we need to buy 3 cans. And that should make sense because if one can cover 300, another can 300, that would be total 600, and we have 700, so we definitely need 3 cans of paint. And then the total cost, let me erase a little bit here. The cost, so part B, cost would be 3 cans times the price of 1 can, 22.50. So the total cost is 67 and 50 cents to paint the walls.